one of the great unsolved mysteries in biology. That one thing that is true is that we seem to be, all complex creatures seem to be, we're called eukaryotes, right? Which is cells with a cell nucleus and all that kind of stuff. And they look like they're the merger between two simpler life forms, bacteria and a thing called an archaean. So it looks like somewhere in 2 billion years ago, whatever it was, in some ocean, the bacterium cell got inside the archaean and survived as a symbiotic organism, essentially, and then somehow, unbelievably, managed to reproduce and replicate in that configuration. And that does seem to be the origin of all complex multicellular life on Earth. So it's called the fateful encounter hypothesis. And if that's true, then it's just a bit of luck, and it happened once, right? And that's why we're here.
Now, when
blind luck.
Consider, like, how many billion Earth-like planets did you say exist just in our solar system alone?
In the galaxy, 20 billion, something like that. So 1 in 10 stars.
So the odds of complex life out of our incredibly fortunate situation, but the odds of that occurring on any of these billions of other planets that exist?
We don't know, but let's say the Earth is, let's say it was on the fortunate side. So we're talking about, give or take, 4 billion years, right, from the origin of life to now. And we have a civilization now, and we've had it. Our species has been around, what, 250,000 years or something? So it's just now, basically. So let's say 4 billion is on the fortunate side. Let's say that it was double that or triple that on the average. Suddenly, that's the age of the universe, right? And that's a third of the age of the universe it took. So how many of those worlds have been stable for 3 or 4 billion years? That's quite a tall order, actually. It looks like our solar system might be quite unusual in that respect, because the planets got to remain stable in a stable orbit. The stars got to remain stable,
at
least in our solar system. Large moon stabilizes. Jupiter plays a big role.
Takes the asteroids, sucks them in.
So, and that, there's a theory called the grand tack theory, which is, so it's very hard to explain the evolution of our solar system. So when you do computer models of solar systems, you don't tend to get 4 rocky planets too close to the sun and 4 big gas giants further out. And one of the current best theories, and I say this because it shows you how lucky we might be, is that Jupiter, they tend to form these big gas giants and migrate inwards towards the star. So in almost all the computer simulations, just because you've got this big gas giant orbiting in all the dust around the star, they tend to drop inwards. And it looks like Jupiter did that. So it looks like it formed and came in almost to where Mars orbits today, and cleared out the region around Mars, actually, which is maybe the reason Mars is so small compared to the other, to Venus and Earth. But then Saturn was coming in as well. And in the computer models, the interaction between Jupiter and Saturn stops Jupiter coming in before it gets to the Earth. And they both get dragged out again. And so to where they are today.
Oh, wow.
And so that seems to be, it's one of the best theories for the evolution of our solar system. So what are the chances? The chances of that are so minuscule, like tiny. So that's the thing I think about these rocky planets. In order to get a civilization on them, I guess you need quite unusual solar systems. And that would be a guess. And you need quite unusual stability on the planet for billions of years. And that's why I think we might be quite lucky.